October 2024, a NASA engineer stares at a screen. The probe has just left the atmosphere. 6 years of work, $20 billion of American taxpayer money, and a single mission: to find out if we are alone. Not on Mars, not on an exoplanet 1,000 light years away. Here, in our solar system, 6 years away. Stay with me until the end of this story, because what you're about to discover might completely change how you see life in the universe. Now you're about to understand why some scientists believe April 2030 could be the most important date in human history, and why the two possible answers are, each in their own way, terrifying. Europa, Jupiter's moon. Here's what we know for certain. Beneath its surface, there is an ocean, a real one. Liquid salt water, wrapping around the entire moon, 2 to 3 times the volume of all the water on Earth, in complete darkness, beneath 18 miles of ice. And it's been there for 4 billion years. How do we know? That's where it gets strange. Europa is too smooth, unnaturally smooth. On any other body in the solar system, impacts accumulate over billions of years. They tell the story of the cosmos like scars on skin. Europa has almost no craters because its surface regenerates. Something underneath erases the marks and pushes fresh ice upward. And those reddish lines streaking across it? Fractures stretching hundreds of miles, consistent with a surface tearing apart above a liquid layer. But Europa is 417 million miles from the Sun. Its surface, minus 320 degrees Fahrenheit. Everything should be dead, except Jupiter is there. Europa is caught in a gravitational tug-of-war between Jupiter, Io, and Ganymede. Their influence distorts its orbit. And that distortion creates tidal forces. Jupiter stretches and compresses Europa's interior with every rotation. Imagine bending a metal paperclip back and forth, over and over. It heats up. Now imagine that on a planetary scale. For 4.5 billion years. That's enough to keep an ocean liquid, in total darkness. But here's the part that should bother you. In 1997, the Galileo probe flew within 162 miles of Europa. Its magnetometer recorded an anomaly, a shift of more than 200 nanoteslas in 3 minutes. The spectrometer detected an abnormal plasma density. No one understood. The data was archived, and for 20 years, no one reopened those files. In 2018, researchers went back to the data, and they realized Galileo had passed through a plume, a geyser of volcanic water erupting from inside Europa, rising 124 miles above the surface. The proof that this ocean communicates with the outside world had been there for 2 decades. Sitting in archives no one had revisited. And that changes everything. Because if Europa is ejecting water into space, there's no need to drill through 18 miles of ice to analyze that ocean. You just have to fly through the plume, capture its molecules in flight. That's exactly what Europa Clipper is going to do. So here's where we are. A giant ocean. Water, carbon, plumes ejecting the ocean's contents directly into space, and a probe capable of analyzing it on the fly. Everything seems to be in place. Except in 2024, researchers published something no one really wanted to read. Simulations of Europa's rocky interior suggest that magma probably doesn't rise all the way to the ocean floor. Not enough heat, not enough pressure, no active volcanism on the seafloor. And without hydrothermal vents, the chemical energy that powers every deep-sea ecosystem on Earth, the one we were counting on for Europa, might not exist there. 4 billion years in the dark. Water, elements, and nothing to start the engine. It's a scenario no one wants to consider. A perfectly sterile ocean, complete, vast, and entirely empty. But before closing the case, there is a process those models didn't include. A quiet, subtle mechanism that doesn't need volcanoes. No magma required. Just water, rock, and time. And Europa has had plenty of time. Life needs 3 things: liquid water, chemical energy, and the right elements. Europa has water, more than all of Earth. The elements? In 2023, the James Webb Telescope confirmed the presence of carbon dioxide on the surface in regions that appear directly fed from the interior. The ocean contains carbon, energy. That's where it gets complicated. On Earth, there are places that look exactly like what we imagine at the bottom of Europa's ocean. Hydrothermal vents in our deep seas, mineral-rich water, total darkness, zero light, zero photosynthesis. And yet, bacteria, worms, shrimp, crabs. Entire ecosystems that owe nothing to the sun. The latest simulations, 2024, show that a process called Serpentinization could continuously generate hydrogen within Europa's rocks, without active volcanism, at low temperatures. And that process could last billions of years, long enough for something to emerge. The question is no longer really, is it possible? The real question is what we do if Clipper finds something. Let's go back to that NASA engineer. October 2024. He knows something most people haven't yet realized, that in a few years, this probe will force us to answer the most unsettling question humanity has ever asked. Because there is no comfortable answer. If the ocean is empty, silent, sterile, without the slightest sign of life, then we'll have to accept a dizzying idea. That even with all the ingredients, even with 4 billion years, life did not happen. That we may be a mistake in a fundamentally empty universe. And if something is there, even a bacterium, even a single-celled organism feeding on hydrogen in the dark, then everything changes. Because it would mean life appeared twice, independently, within the same solar system. And if it happened twice here, Europa doesn't ask these questions. It keeps orbiting, bending under Jupiter's gravity, hiding its ocean beneath 18 miles of ancient ice. And right now, hundreds of millions of miles away, a probe is racing toward it. The countdown is on. Thanks for watching. See you soon. The universe, however, will continue on its own. Like and subscribe to Cosmic Odyssey so you don't miss the rest of the journey.